Everybody. So this morning I want to talk about a few things regarding Unit 2 and your cardiovascular packet and the heart model. And then towards the end, we'll talk about the articulations and cartilage and bone outline. And then my goal for tomorrow is to start the cardiovascular system. So before I get started, does anybody have any questions so far? I know you guys are kind of already moving into Unit 2. So you should have had, let's see, making sure. So you should have had the cardiovascular lab introduced to you this week, right? I think I'm up to speed with you guys. So I want to talk about that, and I want to talk about the heart model and some of the content for Unit 2. So specifically for Unit 2, you're going to be studying the bones this unit. So the bones, I'm going to try to walk you through some of that stuff and the resources we have available. So this is an explanation of how to study the bones. You should be getting that in person. So it's really, you don't really need to watch this. This was kind of more for the online only class, but the information is here if you miss something when you guys are in class or in lab. There is a free resource. We give you guys the pages for the bones book free. So if you guys want those and you haven't purchased the book yet, you can use those right here. So it's in your study resources module, and it's titled Lab Exam Number 2, Main Content, Blue Allen Lab Book. And if you guys click on that, it gives you a scanned copy of the pages. Some of them are a little bit like blurry or something. Like a few students have had a few issues seeing some of the numbers. But it is free, so it should save you however much. You can buy a used copy of this book for like $30, which is what I did. I recommend that. I recommend just spending $20 or $30, but if you want to save even $30, you're welcome to use these pages. It's all of the pages that you need from that book, and it's everything you need. All right, so let's kind of go through it really quickly. I know you're going to get a lot more explanation in lab, so I don't want to spend too much time on it, but just to kind of be clear. So what you guys are learning for your lab exam on the bones is you're going to be studying these numbers and then the different like terms that match the numbers, if that makes sense. So you are not working on the other things on the page. So usually at some point in the semester, you guys start asking, do we need to know these definitions down here? The large orifice and the occipital bone for passage of the spinal cord. No. So you are just learning these numbers and then the terms next to them. Is that pretty clear to everybody? So as you go through it, there are, I've never done the math, but there are, I think, about 200 to 300 terms. So this is a very, I don't want to overwhelm you necessarily, but I don't want to lie to you. This is a very overwhelming amount of information to go over. So I want to make sure that I encourage you guys to pace yourselves. And what I mean by pace yourselves is don't get behind, because if you get behind on this stuff, it's going to be almost impossible to catch up. Okay, so highly recommend that you stay on top of the bones assigned for that week. So for example, these are the bones that you're going to need to know, 18 different basically bones, and then you have to learn all of those terms for those bones. Make sure you're keeping up with whatever's assigned in lab that week. So for example, usually we start with the femur, the patella, the tibia, and the fibula that week. I believe there's also a pacing in the module. Let me make sure. And as you go through each and every week, make sure you're checking in on what is being given to you in the lab. So like if you click on this, it should keep you up to speed as well. This means that this week you should be going over these bones and have a pretty good understanding of them at that point. Does that make sense? I really don't want you guys to get behind, because if you get behind, you're going to just have more and more and more you need to memorize until it's the weekend before the lab exam. You still have your lecture stuff you need to study, and now you're behind on all of these bones, right? So make sure you keep up with whatever your professor gives you that week, if not getting even more ahead of that. Again, you have your complete list of everything you need to know for the bones and the pages available to you free in your study resources module. Study resources. Under lab exam number 2 main content, Blue Allen lab book, you have your complete list of all of the pages you need, and then the links. This is just the link for the foot because we were missing the foot page, so we added the foot. Does that make sense to everybody? So you have all of that available to you free. And then I want to walk you through really quick how I studied the bones. Other people kind of recommended it to me when I was taking the class, and I found it to be very helpful. So one of the things that was recommended to me by others was to organize the bones in a way that you can go through it the same way every time. So let me see if I can show you. So if we look on this one, try to annotate. We look on this bone, do we see number 1? Everybody sees number 1. So this is for the femur. So page number 30. Yeah. So if we go to number 1 is the head of the femur, right? And then number 2 is the neck, okay? And then number 4 is next, okay? I'm just trying to kind of show you. And now we don't see number 3, right? So number 3.
Number 5 is lesser. This place is shaft. Number 12 is shaft. This one is something chondral. Media. Aethna is lateral. This place is media. Media epicondry. Media
chondra. Are you?
Oh,
sorry.
I think I was.
Did you have a question?
I'm so sorry.
No, it's okay. You're doing great. That's great. I was just wondering if you could mute, or if you have a question, that's fine too.
It was mute. Sorry about that.
Okay, no worries. So the first one is 1, right? 2, 4, 5. And then this is what I want to show you. So do you see how the next thing down is 12? And then if we go down from there, it's 7, and then 10, and then 11, 9, and 6. So hopefully at this point you're seeing how they don't go in order. So for some reason, the people who made this book, I don't know what was wrong with them. They didn't just do 1, 2, 3, 4, 5 all the way down. They decided to jump through the numbers, which the book is really good, but that's really unhelpful for learning. So what I did when I was studying the content is I just reorganized the list, like on pencil or on another piece of paper. So I just made a list that went logically through the bone. And the reason is that way every time that you study the bone, you can go over it the same way. Is that making sense to everybody? So each time that I go over it, I'm going over it starting at the top and working my way all the way through the bottom, instead of jumping back and forth, trying to go in order of 1, 2, 3, 4, 5, all the way down. Okay. So this way, when you're studying it, you can quiz yourself. So when you're going over it, what I recommend doing is in the beginning, you kind of make this list. I think that's 11. You make this list, and then as you study it, you're going to go back to this list and use it to quiz yourself. So just to kind of show you the whole process of what I did, I would create this reorganized list, and then I would kind of teach myself the different parts on the bone, kind of going over it over and over. And then I would actually quiz myself. So the way I would quiz myself is I would write out the numbers, because usually you're not going to memorize the numbers, right? So I would just write them out to tell myself how many I needed to remember, if this is making sense. And then as I practiced or quizzed myself, I would write down on my piece of paper what I thought number 1 was, what I thought number 2 was. And then at the end, I would go grade myself with the answers. Does that make sense? So it's a way to practice where you're actually actively testing yourself instead of just thinking you know it. And then, you get to the test and that's the first time you've quizzed yourself and you find out, I really don't know any of this. So make sure you figure out a way you can quiz yourself. If that's practicing with a friend and they quiz you, great. But if you're kind of somebody who studies mostly by yourself, this is a good way to kind of quiz yourself, make yourself an organized list, and then write it out so that you know how many are on that list. And then you can fill it in and grade yourself at the end and see how many you were missing. Does that make sense? And then finally, my last kind of piece of advice is don't move on until you understand the bone. I don't know what percentage to give it, but I would give it 80 to 90%. You don't need to understand it 100%, but you do need to understand it 80 to 90%. Okay, so make sure that you go through it and you make sure you go through it enough that you are moving on to the next bone, understanding the bone 80 to 90%. And don't forget about the back of the bone. I know that in this example, I didn't go through the image on the right of the screen, but you need to know all of that as well. Okay, so usually for me, when I would go through the bone, I would go, top to bottom like this. And then I would start on the bottom I would flip it over and then I would go bottom to top. Does that make sense? I would kind of do all these bottom ones and then I would do the bottom ones when I flipped it over. And then I would go back up towards the top once I turned it. So that's just kind of how I liked to do it. So when you reorganize the list, I would have done like 12, 13, 14, 11, 10, 9, 16, 15, 6, 7, and so on. Does that kind of make sense to everybody? So I reorganized the list for every single bone in these pages. I always reorganized my list and I always tested myself over and over. And I did do very well on the lab exam because of that, because I just went over it and over it and over it. One of the things you guys will see as you go over these is some of the names are really, really similar and really confusing to the point where it's really hard to remember them. So that's why I do recommend writing it down, because when you write it down, you will be more successful on the exam. You don't have to do a fill-in. Technically, it's multiple choice. However, there are some of them that are only one letter different. So the example is conoid. This is just one example that is very close. Conoid and coracoid tubercles. These are like almost identical words. There's also one that I'm not thinking of right now that has only one letter difference. But basically, these are two words that sound almost identical, but the coracoid tubercle is located on the clavicle, and then the conoid tubercle is located on the humerus. So this is why when you study them over and over, you start to notice these things and you get to that exam question and you're not tricked when the professor throws in conoid and not coracoid. But if you've only gone over this stuff a few times, you may not remember it exactly. And you're like, that kind of sounds right. And you pick that option and then it's not correct. Or you choose it and it was actually supposed to be E, none of these, and none were correct, right? So hopefully you guys feel a little more direction on how to study these. Again, I would recommend reorganizing it and testing yourself as much as possible. And don't get too behind on these. I probably studied these when I was in the class 2 to 3 to 4 hours a day. So I never studied with the pictures in the book. That's a great question. I would highly advise you guys not to use the pictures in the book to study. I would say that that'll probably lead to disaster on the exam. I would definitely study with bones. When I took the class, I did have a skeleton that I rented from somebody. I believe that isn't the school still making the skeletons free to you guys to take home? I think that that's still happening. So when I was in the class, I had to pay $100 to rent somebody's skeleton, but now you guys actually have it free. So I can't tell you enough how amazing that resource is. I would highly recommend that you guys take advantage of the free. They're not free to keep, but they're free to use that the school makes available to you. So definitely recommend that you guys do that. All right. Where do you go to get that? So I believe that this free skeleton is through the library. That is a really good question for your professor. He should understand exactly where to tell you guys to go. It's either through the library or the bookstore. Just ask your professor and he should know. Yeah, maybe it's in the classroom. So sorry, I'm not sure because they had it out of the bookstore at one point during COVID and then they changed it. So your professor, Knutson or Bender, they will know the answer to that a little better than me. Yeah, I think Knutson has them all in the back of the classroom. All right, any other questions on bones? Hopefully that gives you guys a pretty good direction. So this weekend, get started already. Maybe go pick up your bones tomorrow or today if you're on campus. And start going over them immediately. Don't waste any time on these. Again, I would go over them when I was in the class, 1 to 4 hours, depending on the day, but I did go over something every day. So that was how I studied them because they're very exhausting. So don't leave, don't say I'm going to go over bones for 8 hours on Saturday. You need to go over them a little at a time so your brain doesn't get as overstimulated with all of these terms. Any other questions on bones at all? So you remember how this last exam had tissues, right? Tissues was the main thing on the exam. And then you had all your models, right? This time it's bones, and then you'll have all of your models again. So you don't just study bones, you have to study bones and then the models. So I'm going to show you guys some of the models that we have this time, and I'll go over the heart with you. All right, so the heart model. So this is our first model we have you guys cover for this exam. For all of the models that will appear on this lab exam, we have a video of a previous SI leader going over the models. So if you guys click on the video right here.
So we'll start out with the right atrium, which
he will go through the whole entire model and tell you where every single part of it is. And if you guys go right here to settings, everyone see this? Okay. Quality, you can actually change the quality to the HD or 1080p. And then that way, when he's going over it, it will be really high, high resolution, and you can see all of the different parts that he's going over on the model, okay? So he'll go through each valve and everything, but I'll also go through the pictures. That way you guys have some pictures labeled for you. But these are available to you guys for every model for the lab exam number 2. Okay. I really want you guys to be able to use these as a resource. I think a lot of students maybe thought that because it's a previous semester, so we're always using this same list every semester that we need you to know. So there's nothing that's changed about this semester to semester. We always use this list. So this is the list we expect you guys to know for the test. Does that make sense? And that's the same list that he's going over in the video. So there's nothing different there, semester to semester. It's the same exact list. And so these are videos available to you in every model in the Google Drive link. So we have a heart model, a larynx model, a trachea model. Each of them has a video of him going over the model. Okay, so you can watch that whenever you guys are at home and you're studying. Okay, so again, there's going to be additional models coming up on this exam: larynx, thorax, blood cells, standing kidney, digestive. So these are the different models you're going to be responsible for on the upcoming exam. So again, 2 things, you're going to be working on the bones, and then you're going to be working on the models, bones and models. Okay, let's take a look at the cardiovascular lab packet. Will the numbers be on the model on the exam? So it's the same model. So we use the same model on the exam that you see here. So yes, some of the numbers will be there. However, a lot of the time when we put the sticker on the actual model to ask you what it is, we might need to cover up the number, okay? And that's not necessarily to trick you. Sometimes it's just because that's where we have to cover it. So if you're only memorizing the numbers, we might have to cover it with the tape on the exam. But that's not always the case, but it can be the case, okay? So don't just look at the number, but yes, the numbers will be on the model. We're not gonna like erase them all, but we might cover it up with the tape like this. Does that make sense? 30 was underneath and now it's covered up with the tape. All right. Somebody asked about the bones. You asked if they were only available in the library. So no, the bones that are available through the school are available for you guys to take home ever since COVID. You guys can take them home and study them at home. So you have a complete, they send you home with, it's either a complete or one side of the skeleton. And you can study all of those bones while you sit on your couch or wherever in your room. And as long as you return them to the school complete, you have to pay you have to put down a deposit, but or maybe it's just put down your credit card or something. Anyway, it's free as long as you return them without running over them with your car. It's fine. You don't as long as you don't damage them. Some people were worried about their kids breaking them. They're very sturdy, so it's almost impossible to hurt the bones at all. All right, so the cardiovascular system lab packet. And I will plan to go over the heart model at some point, but I kind of want to talk about this right now. So the cardiovascular system lab packet, this is your only lab packet for Unit 2. So remember how you guys had the metric packet and the mitosis packet and the microscope packet and the tissues packet. Now, all you have is this cardiovascular system lab packet. And it's not really tested on the lab exam. And I'll explain what I mean by that, okay? So most of this content in the packet is more geared towards the lecture exam. So there's a lot of really good information in here about how the heart pumps. I highly recommend you guys read through this. It's really, really helpful. It's really clear. And a lot of it is stuff you need to know for lectures, but it's explained in one place. Does that make sense to everybody? Print it out and keep it somewhere handy that when you guys are going over the lecture for the heart, you have this handy near you because it really is helpful. Okay, it's a nice, simple way to explain the heart. So there's quite a bit. That's because this cardiovascular system is going to be very heavy with information for you guys. Okay, so there's quite a bit in here to read. Okay, so let's look at the questions of the packet and we'll kind of go through how to answer those. So for 5A, 5B, and 5C, these are the first questions in the packet. The answers were already given to you right here. Okay, so the answers to 5 are actually on page 5. Okay, just know that you do need to have an understanding of what those things are saying. They're talking about how the pulmonary circuit circulates the lungs with blood, the coronary supplies the heart itself with blood, and the systemic goes to the body. But these will give you guys the answers to page to the 5A, 5B, and 5C. Good. Moving on to 5D. So this says, describe what the hepatic portal system consists of, what does it do, and what does it connect? And it says this question will show up on your lecture exam, and we will discuss it when we visit the digestive system. So the way that you're going to find this answer is you're going to go to either Google or your textbook. I actually would recommend probably Google. Your textbook is really hard to understand for some reason on the hepatic portal system. I remember when I was in the class having to read it for like a long time before I even tried to figure out what it said. So Google this really and get an answer. And if you're curious if your answer is correct, you're welcome to text it to me. Canvas inbox it to me. I get it on my phone. And I can tell you if it's right or wrong, and I can tell you what the right answer is, but do a little hunting to get that answer. And then you can also ask me in tutoring or in a future SI session, and I can give you the answers in a future SI session, but I want you guys to try to Google it first. Where is cellular waste removed? So I will give you the answer to this one just because there's one we're looking for, but there's a lot of answers. So technically, the primary place that cellular waste is removed is through the kidneys, but it's also removed. So this is a lot of other answers we get. So sometimes people will say the skin, because I think that's probably what Google tells you. The skin also helps remove it, and the lungs, because the lungs remove like carbon dioxide, right? So the skin and the lungs also help with removing cellular waste, but the kidneys are the primary place to remove cellular waste. What is the space between the lungs called? If you read the information on all of those pages, you'll find the answer. Does that make sense? So all of those pages in the beginning of this packet will tell you the answer to 5F. Same for 5G. Read the packet and it'll tell you the information. Okay. And I'm not giving you the answers just because I'm trying to show you guys exactly where to go for the answers. And then hopefully that'll be easier for you to find them. So again, 5F and 5G, both of those informations are found right here in the packet. And the same for 5H, name the layers of the heart. I know you can't really see heart, but that's what it says, layers of the heart. And same thing, you can just read the packet and you'll find those answers right here in the packet, okay? So we'll kind of go down a little bit and cover the other questions here. So what would happen to the heart if the hormone epinephrine or norepinephrine were introduced into the blood vessel? So this one is a little bit, this one's a little bit hard. You can Google this. I've had a lot of variety of answers. So I think I'm going to just give you guys the answer to this because, again, Googling sometimes leads you to like a lot of information or not enough. So these hormones make the heart contract more forcefully. And they accelerate the heart rate and they increase blood pressure. Okay. So they make the heart contract more forcefully, they accelerate the heart rate, and they increase blood pressure. So why? And I this is the reason that I wanted to tell you guys, because sometimes Googling it doesn't really give you this. To help your body when it's in danger. Okay. So let's say you are, you're in a dark alley and you notice that somebody is chasing you down the alleyway with a knife. What do? Your adrenaline, we always say your adrenaline jumps in, right? And you start preparing to run away. Well, adrenaline is the same as epinephrine. Those are just different names for the same thing, adrenaline and epinephrine. Norepinephrine is called noradrenaline. So they're just adrenaline. People say adrenaline junkies, right? They like to go jump off buildings and stuff like that. So this is when you feel that heart racing and you go run away from the guy with the knife. That is when your heart is pumping harder to supply your lungs with more oxygen, to get more blood to your legs so you can run more effectively away from this guy, right? Because your body needs to work harder to help you get away from danger. Does that make sense? It's kind of like everything's working more. There's more blood to your lungs. There's more blood to your legs, like your skeletal muscles, basically. Okay, so here's a little question, and then that way you guys can answer the next question in the packet. So during the time you run from danger, which of these has the least blood flow? Okay, so we're going to choose. So it's select. These are, you guys haven't done a lot of these. Select all that apply. These are my nursing school questions. So lungs. Okay, so let's read the question again. So during the time that you run from danger, which of these has the least blood flow? So we're going to select all that apply. Which of these has the least blood flow? It's okay if you get it wrong. We'll just throw some guesses out there. Good. One guess. Remember, if it's select all that apply, that means you can choose multiple options. Good. 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 All right. So everybody's getting it. So that's correct. So C, D, and E. So when we run from danger, these two get the most blood, right? These, like I told you, the lungs, the legs, things that are helping you run away. These are the most blood. But the kidneys to make urine, is that a priority when you're running away? Probably not. Digestion, is it really a priority for you to digest your food when you're about to die? Probably not, right? Your spleen kind of helps filter blood. Again, it's not the priority when you're running away from, death. So that's correct. So during the time you run from danger, the kidneys, the digestive tract, the spleen, those actually have the least amount of blood flow, and we're supplying more blood to the lungs and the legs that are the priority. Great job. Okay, so now let's answer the next question and see if you guys can kind of use some of your critical thinking, get you going into physiology a little bit. So for 5J and for 5K, you can find these answers by reading the packet and by reading the packet. Again, if you guys need help with answers, you're welcome to come to tutoring. Ask me tomorrow in SI. I can go over the answers if you kind of fill it out tonight. And then you're also welcome to message me on Canvas. So let's answer 5L. So under what conditions would you expect the flow of blood into the renal pathway, remember this means the kidneys, to be the greatest, and why? So when do you think the blood flow to the kidneys is the greatest? So we just said that the least amount is when you're running from danger, right? So least blood to the kidneys when you're running from danger. Okay, and we're kind of getting you a little bit of, we're getting your wheels turning for physiology. So anybody, can you guys give me a guess? If that's the least blood when we're running from danger, when do you think we would have the greatest amount of blood to the kidneys? Good, good. So I had two people say it right away. So I don't know if I guided you good or you already had the answer, but either way, great job. So sleeping. So when we are asleep, this is when our body prioritizes filtering the blood. So because the kidneys filter the blood, our body prioritizes that the most when we're asleep. It doesn't mean that you don't filter blood throughout the day. Obviously, we all urinate throughout the day, but it's kind of like how whenever you wake up, you have to pee, and usually you have to pee a lot. That's because your kidneys were working overtime all night long to make a lot of that urine, because they're really filtering your blood a lot when you're asleep. Does that make sense? So that's why I like to answer those two together, epinephrine and norepinephrine when you're running from danger. And then we kind of go to the flip side. The flow is the greatest when you're actually asleep. Okay. All right. So again, 5J, 5K, we can read the packet to find those answers. And I'll go over them in the future, but I want you guys to look over that some by yourself. So for 5M, this is a really, really great exercise, because what you're going to do with 5M is you're going to go through this and renumber all of these that are here, putting them into the correct spot. So for example, I'll give you the first few to get you started. So from the left ventricle, where does blood go first? From the left ventricle, blood goes to the semi-aortic, semilunar valve. From the aortic, semilunar valves, it goes into the aorta. Once it gets into the aorta, it goes into the systemic arteries. So that's going out to the body. That then branches into systemic arterioles, and then a systemic capillary bed, which is when it changes from being arterial to venous. And then we're going to come back to the heart as systemic venules, and then systemic veins. So as you guys go over the heart more, this will all start to come together. It probably feels a little bit overwhelming right now since you haven't had a lot of content with the heart, but basically the heart will pump out, and it kind of branches into all these different vessels that go to different places. And then the really shortened synopsis is that as the blood comes back to the heart, it's coming back as veins, right? So arteries go away right here. This is an artery. And then the veins will come back. And we'll talk a lot more about that when we talk about the heart. But this is to show you guys how you would be filling this out. Does that make sense? You're going to trace the blood flow through the heart when you fill this out. And you should be able to find most of the answers in the packet. And honestly, as you guys go through the heart, this is a really good way to quiz yourself. You should be able to answer this without looking at the answers as you get closer to the exam and you've gone over the heart more. Okay. But right now it's still pretty fresh. All right. Any questions at all there? Kind of getting towards the end of the packet, just a few more things we need to go over.
Bro, please, can you go back, please? You've erased it already.
I think it would be better to I don't really want to refill it in, because I just wanted to give you an example of how it will look. It's right now, I think it would be better to you guys put in the work to fill that in. So I'm not going to put it back in, because I was just trying to show you how to do it. I think it'll help you more if you guys go through and you do that yourselves to fill it in, because it is stuff you need to know for the lecture exam. So I don't want to refill it in. I didn't want to, my goal isn't to give you the answers. My goal is to help you find the answers, right?
Okay.
So for the rest of the packet, the one thing I don't want you guys to forget to do, these are like helpful diagrams. On page 16, is everybody seeing page 16? You have to fill this out and label it. Okay, if you guys don't label this, I believe it's 3 or 4 points you miss, it's just easy points to do. And the fastest way to label this is, everybody see it says Pearson Education. So what you can do is you can look up 2006 Pearson Education heart diagram. And then it will pop up for us the same picture right here. Everybody seeing this? I know it's blurry. Okay, now it's clear. So this is, This is the same picture. I can't really zoom, it won't let me zoom. Oh, here we go. This is the same picture that there is right, oh, whoops, right here. So if you Google 2006 Pearson heart diagram, all you have to do is hold this next to your cardiovascular lab packet and you can fill it in. Does that, everybody got that? Just Google 2006 Pearson heart diagram. All right, so this, oops, no one can read that. This specific diagram is not on your lecture or lab exams. So I want to be clear, there are some terms on here that you need to know for the lecture and lab exams. However, you can find them on the heart model. So you don't need to really know this. So that's why I'm just showing you that it's really just an activity for you guys for the packet. It's not something that is where we're going to test you. So where we're going to test you again is on that heart model itself that I already showed you. And this is the key that you use to fill out the heart model, right? Is that making sense to everybody? This is the list we expect you to know. This is the model we expect you to test on, not this diagram. Good. So that's why I'm showing you how you can fill it out really quickly by just Googling 2006 Pearson heart diagram and filling it in using the image. Good. But just to be clear, you're going to need to spend time memorizing this model because that is where we'll test you. Okay. So finishing out, this is the list that I've shown you a few times now. Again, this is the heart model, and this is the list you have to be tested on. So this is in the cardiovascular packet as well. You will notice there's 62 terms, but there's some that are missing. So it goes all the way to 46, and then all of a sudden 46 to 51, 51 to 59. That's not an accident. You guys are not required to know 47, 48, 49, or 50. That makes sense? You're not required to know 52, 53, 54. You just need to know this list. If a number is missing, that's intentional, it's on purpose. Yes, that's a great question. So Alyssa said, is it mostly identifying rather than identifying and knowing all the functions? Yes, so the lab exam this time is all identification. There's like 1 or 2 function questions on the models, but as far as all of the like bones, there's no functions on the bones. It's just, what is the name of this part of the bone? What is the name of this part of the bone? There's no like, you know, where is it located? What are the special terms? So for me, I kind of felt like the bones were easier because it wasn't as like hard to figure out as the tissues. But time-wise, I think the bones maybe took more time. I'm not really sure, but because of all the terms, it kind of took a while. Okay, so I know that it feels like I've been talking for a while about the cardiovascular packet, but we're almost done. So just pay close attention to this part, okay? So the last 2 pages, page 19 and page 20, these say arterial flow, tracing the blood flow, and then venous flow. You, I don't think Bender's doing it, but if you're in Knudsen's class, you will have a quiz on these last 2 pages where you have to fill in the blanks in between these words. Okay. So again, if you're in Knudsen's class, you will have a quiz on these last 2 pages. No matter which person you're taking, these last 2 pages are not on the exams. So just on the quiz. The quiz is worth 20 points. There's going to be 1 example from this page and 1 example from this page, each worth 10 points. I believe it's 1 and 1. So what you're going to do to fill these out and then to test on them, to memorize them, is you have to fill in the blanks. Okay, so I know it's sideways, but I'm going to just write out what it says, and then I'll show you guys how you would do that. So let's look at one. It says brachiocephalic. Then it says, has a big space, right? And then it says ulnar artery. And then at the end, it says palmar digital. I know you guys can't see digital. I'll scroll up a little. Palmar digital. Everybody see that? So there's just 3 words and then blank spaces. So what you're going to do is you use these images that are in the Google Drive packet to fill in the blanks. Okay, so again, where do you go? You're going to go to the Cardiovascular Lab Google Drive link, which I already am at right here. When you click on it, you can find the packet and these 4 images. So what we're going to do is look at the top. Do you guys see how it says arterial supply of the arm, arterial supply of the leg, venous drainage of the arm, venous drainage of the leg? Is everybody clear on that? So on those last 2 pages, when it said arterial flow and it said venous flow, we go to these pages to fill it out. So let's look at our example that I did, brachiocephalic to ulnar to palmar digital. And I'm going to zoom in here. So everybody see how this right here at the top says brachiocephalic trunk? Yes? Oh, it deleted my words. Okay, this was brachiocephalic over here. I'll have to retype it. So this was brachiocephalic was first, and then it was ulnar, and then it went to palmar digital, right? So let's find those 3, and then I'll show you we fill in the blank. So brachiocephalic, here's my ulnar, and palmar digital is right down at the bottom, but it starts right here. So we'll just circle that. So what I'm going to do is trace the arrows over to my next word, and then I'm going to fill in the blank between them. So between brachiocephalic trunk and right ulnar, I have right subclavian, right axillary, right brachial, and then I get to right ulnar. Does this make sense? Then I get to ulnar. And then the next blank is right superficial palmar arch. And then I get to my last one, which is the palmar digital. Do you need to know right and left? For the arterial arm, no right and left. This has to do with the blood flow off of the aorta of the heart. For the rest, do not need to know right and left. So for the arterial leg, venous arm, and venous leg, you do not need to know right and left. But for the arterial arm, you do need to know right and left. Remember, you have a quiz on these. So how do you study for the quiz? You need to memorize what goes in between to fill in the blanks. So you would be memorizing right subclavian, right axillary, right brachial. If you are on the quiz and you don't get all of those, let's say you just remember subclavian and that's it, you won't get the full 20 points. You're going to get docked, I believe it's 2 points per missing word. So these are kind of easy points for you. When I was taking the class, I did spend a lot of time having to study this because it was kind of confusing for me. I used to make diagrams of I drew an arm and then I would draw the vessels on the arm. That's kind of how I am. I'm very visual, but maybe you're somebody who memorizes easier and you could just make flashcards. Maybe flashcards would be really good for this. And you could just kind of quiz yourself. What's the next one? What's the next one? What's the next one that fills in the blank? Does this make sense to everybody? You have 10 different ones you're going to do. So this was example 1, brachiocephalic to ulnar to digital. There are 10 different examples of ones you have to fill in the blank. So you're going to use these images to fill in the blanks for the different examples. Okay. Does that make sense? Is that good? Everyone kind of getting that? So if we're looking, I'll just show you a little venous one real quick, and then we'll done with this. So if we're looking at venous on this last page here, dorsal, let's do proper palmar digital, superior vena cava are our only prompts. Proper palmar digital. And then we're supposed to fill the blank in all the way until we get to superior vena cava. So let's look, that's going to be the arm because superior vena cava is the arm one. And if in doubt, you guys can just go to the different images and find the ones you need. So if we're looking at this image here, trying to get just out enough. Okay, well, superior vena cava is at the top. So everybody just believe me that superior vena cava is the top because it won't let me fit it. So you're going to go all the way down here to palmar digital right here. And then you're going to trace all the way up until you get to the superior vena cava. So you have to memorize everything that comes in between those two words. So the reason that this quiz is hard is because there's a lot of variety of which prompts you're going to get and memorizing those, but you need to memorize right common palmar digital, right superficial. You don't need to know right, like I said, as long as it's not the arm, the arterial arm, you don't need to know right. Common palmar digital, superficial palmar venous arch, ulnar, brachial, axillary, subclavian, and then there's two more at the top of the screen, right? Brachiocephalic, and then it leads to the superior vena cava. Does that make sense? The expectation for the quiz, you guys have to memorize all of the stuff in between. And clarify with Professor Bender, I don't believe he's doing the quiz, but that was last semester. He might have changed to this semester and be doing it now. He has done it in the past. Either way, you have to fill this out for the packet. So whether you have the quiz or you do not have the quiz, you will not get full points on the cardiovascular lab packet if you do not fill these in. So the way that I showed you to fill them in is how you get the full amount of points possible using these images on the Google Drive link. Does that clarify it for everybody? Make sure you confirm with your professor. I don't think that Bender's doing a quiz, but make sure you ask him just to make sure, okay? But regardless, you need to use this to fill in the packet. Are there any questions on that? Any questions on the lab exam 2? So again, our main content is our bones. We also are going to have our models just like before, but this time you have a list for each model. You don't need to know functions unless there's like a very specific one. And we have videos for the models for you guys. And then for the cardiovascular lab packet, this is your only lab packet, and the majority of it is lecture content. The only thing on the lab packet that is lab exam content is the heart model. The only thing on the cardiovascular lab packet that will be on the lab exam is the heart model. Everything else is lecture content. And then the quiz if you have the quiz. But that won't be on the exam, the quiz won't. All right. Any questions at all on this content? Any questions at all on this content? Are you guys good with going through the heart model right now, or do you want to do some lecture stuff? I wanted to do like an outline of the articulations and cartilage and bone. Do you want to go over and do those, or you guys want to do the heart model right now? Sorry, I'm looking at the chat. It seems like people are tied. Let me see. 1, 2, 3, 4. 1, 2. I think I'm getting more people for the lecture side of things. I do really feel that the lecture would be more beneficial to you guys. Like I said, you guys have the video available here for you of the model, and I do plan to go over it anyway today. But I just want to make sure we're all on the same page. I don't want you guys to feel like I'm not going over the models, but I do feel like lecture is a better use of our time together. Okay, let me grab my Apple Pencil. Okay, so articulations is your first topic that will appear on your lecture exam number 2. So remember that the exams are not cumulative. So what that means is all of the information you guys just finished going over, you really won't be tested on again for the rest of the semester. Okay, we might have a few questions on the final, but overall it's not a cumulative class. They're just don't worry about that. There's like 2 or 3 questions on the final, but I can kind of point you guys to what those are when we get there. So remember, on unit 2, you will not have any of the information you just went over. So no tissues, none of that. This is all new stuff. So for the articulations chapter, the best way to kind of go over it quickly for you guys, because I don't want to belabor it, is to go over it as an outline format. So articulations, these are joints. Remember, our quick definition of joints is where bone meets bone. That's the fastest definition, but it could also meet cartilage or teeth and still be considered a joint. So that's kind of a little odd, right? Like your teeth, your gums, that's a joint, the same way that your knee or your elbow is a joint. So articulations are divided into 2 major topics. When we talk about them according to their function. So they're joints according to their function, or joints according to their structure. And when we talk about their function, I'm going to throw a little bit of definitions in here, okay? Because I feel like that's how we can actually learn this. So function is how much they move, whereas structure is what holds them together. So what holds the actual joint together, versus how much does the joint move. So we say that the function, how much it moves in 3 ways. It's either synarthrosis or synarthritic, which means it has no movement. Or it can be amphiarthrosis, which means it has a little bit of movement, some movement, a little movement. Or it's diarthrosis, which means it is freely movable, it has a lot of movement. Your shoulder is diarthritic. Remember how you were a kid and you used to do like wheels with your shoulder? Your shoulder is diarthritic. Your skull is synarthritic, right? You can't move your skull around a lot. The bones within your skull. Okay, when we look at structure, structure is divided into basically 3. So we look at structure number 1. These are fibrous joints. These are joints held together by dense, regular connective tissue. Then we have cartilaginous joints. It's not too hard to guess what holds cartilaginous joints together. It's going to be held together by cartilage, right? Specifically, fibro and hyaline cartilage. If you remember your locations, where was elastic cartilage found? Wasn't it found in the ears and the epiglottis? So doesn't it make sense that those aren't joints, right? The ear would not be where bone meets bone, cartilage, or teeth, and the epiglottis is in your throat. So that's why cartilaginous joints are just fibro and hyaline. And then our last type is synovial. Okay, so synovial is held together by a synovial joint. We'll talk about that. Okay, so these are our three types according to structure. So when we go into fibrous joints, we have more subdivisions under that. So our first type of fibrous joint is our gomphosis joint. Okay, so the gomphosis joint is found in the gums. And I'm going to try to write small, but I do want to give you guys the information you need for the test. So if that means I have to open a new page, I'll just open a new page. So this is between the teeth and the maxilla or mandible. Remember, your mandible would be your jaw. Your maxilla is your upper jaw. So the teeth in the upper or the lower jaw. And then the big thing that we have to do when we talk about each type of joint is we classify it according to its movement. So I'm going to do this like this. So gomphosis is a number 1. What is a number 1? A number 1 is a synarthritic joint. Your teeth, if you wiggle your teeth, do you want them to move? No, you don't want any movement in your teeth as an adult, right? So that's because they are synarthritic, they do not move. So our next classification of fibrous joint is our suture joint. Our suture joint is found in between the skull bones, so in between your skull. Do you think you want those to move? No, it's a number 1. It is a non-movable joint. The third type of fibrous joint has 2 names, syndesmosis or interosseous. Okay, so 2 names there. So make sure you guys know both of those names. And the location is between the tibia and the fibula. That's your lower leg, or between the radius and the ulna, and then that's your lower arm. So think about your lower leg and your lower arm. We have a little bit of movement in between those, right? If you kind of press on your lower arm and you move your hand back and forth, you'll feel that the bones kind of give a little bit. So that's because we want to have a little bit of wiggle room there. So this is a number 2, an amphiarthrosis joint. That making sense? Hopefully everybody's with me. So that's everything for the fibrous category of joint. Fibrous. Good. So now we'll work on our cartilaginous joints. So cartilaginous only have 2 types. They have hopefully, wait, maybe we can't read that. Let me write it bigger. Synchondrosis. So that right away, you're like, wait, that kind of sounds like syndesmosis. So make sure you look at those different, right? Synchondrosis sounds like cartilage, This is made of our hyaline cartilage. Okay, locations are the intercostal cartilage. So specifically, where is this? This is where the ribs meet the sternum. Okay, so this is also named costochondral. So on your test, you might see it as costochondral, maybe as intercostal. And you need to know that that's where the ribs meet the sternum. It's also found at the growth plate or the epiphyseal plate. Okay, the growth plate or the epiphyseal plate is where the shaft of a long bone meets the head of the long bone. So we can kind of draw it, right? This is like our shaft of the long bone, and then it has 2 ends. So at this point right here, This is the meeting point, and this is the growth plate or epiphyseal plate. So when somebody is growing up and they're getting taller and taller, this is where that's actually growing and allowing length in the bone. So what type of joint is that? A synchondrosis joint. Where is it located? It's located intercostal and at the growth plate of long bones. How much does it move? It has no movement, so that's a number 1. It's synarthritic. It may be a little bit confusing because you're thinking, wait, didn't she just say that it moves when somebody's growing? It doesn't move. It's more that it allows for growth. They're just technically different. It sounds the same, but they're different. So technically we say that it does not move. Okay. So then we have our second type of cartilaginous. Remember, there are just 2 types, and this is called a symphysis joint. It's made of fibrocartilage. And this is located at the pubic symphysis. The pubic symphysis is where the pubic bones meet. So your hip bones meet. When you walk, you can kind of picture this little meeting point right in between the pelvic bones, kind of at the groin area, and this is the pubic symphysis. And then the other place is the intervertebral discs. So these are in between the vertebrae. So as you walk, these kind of cushion your step. You know, when they say someone has a slipped disc or a herniated disc, those are the discs in between the vertebrae. Okay, so those are both symphysis joint, the pubic symphysis in between the pubic bones, and then the intervertebral discs in between the vertebrae. It probably sounds a little like some movement is required, right? Every time you walk, you have a little bit of movement in between the vertebrae and a little bit of movement in between the pubic bones. So this is a number 2, an amphiarthritic joint. So that's everything for synchondrosis and symphysis, both of those being our cartilaginous joints. Okay, and synovial gets a little bit detailed, so we'll do that on a new page. But what we're going to see with synovial joint is it doesn't have different types of joints, but we're going to talk about its anatomy. So the anatomy of the synovial joint is one thing you're going to be tested on. The accessory structures, and we'll talk about those. And then our planes and our movements. So those are all the things you'll talk about with the synovial. Again, just to be clear, you don't have types of synovial, but we have different terms we need to know with synovial, and we'll talk about that on the next page. Everybody got that? So 3 types of fibrous, and we talked about locations and how they move. 2 types of cartilaginous, locations and how they move. Good. All right, so moving on to synovial, remember that this is, I'll just write it at the top. So this is our articulations, and this is according to our structure. And we said that structure was what holds them together. So if it's a synovial joint, that's what we're talking about right now. We already did fibrous and cartilaginous. So now we're on our synovial joint. So synovial joints, again, these do not have multiple types. They are the most common joint in the body. Type of joint. So they're found in a variety of different places. So examples, your elbows, your knees, your shoulders, all of those are synovial joints. You even have synovial joints in your fingers. Okay, so they're found in a lot of different spots. They are our freely movable diarthrosis joint. So our only freely movable joints are our synovial joints. If you look back here, do you see how we had a synarthritic 1, 1, 2, 1, 2? So we never had a number 3, right? So number 3 for the first time is our synovial joint, is our freely movable joint. Okay. So looking at our anatomy of the synovial joint, anatomy, we break it down into the articular capsule, which surrounds the synovial joint. So if we kind of picture, if this is your femur and this is your tibia, and we're picturing your knee, the articular capsule kind of wraps around it like this to kind of make this little chamber. And the articular capsule has 2 layers. It has a fibrous layer, which is made of dense regular connective tissue. And obviously, of course, you need to know this for the test. And it strengthens the joint. So that's the first layer. And then our second layer, we'll do it in a different color. Let's do green, is our synovial membrane. Okay, and our synovial membrane secretes synovial fluid. So if we draw this on here, maybe we have 2 layers and we picture the outside is that blue fibrous and the inside is our synovial membrane. Okay. Our function of our synovial fluid is to nourish the articular, oh, we probably can't read that. Let me rewrite it. Nourish articular chondrocytes, because there's those cells inside, right? Nourish articular chondrocytes. So they're giving them the nutrients they need, and it also absorbs shock. Okay, so absorb shock nourishes the articular chondrocytes and lubricates the joint. So if you picture the fluid, I'll kind of draw it like these little squiggly lines. That's kind of our fluid sitting inside our joint. So that's our synovial fluid. Remember, they're called a synovial joint, and that's really because of the synovial membrane, synovial fluid. So that's the first thing, is our articular capsule having its 2 layers, which is the fibrous and the synovial membrane. Okay. We also have the joint cavity. Okay, the joint cavity is basically the space with the synovial fluid. So that where the synovial fluid is, it's inside the joint cavity. So the joint cavity is kind of that space I basically drew between the 2 bones. In addition, we have ligaments and we have tendons. These are both part of the synovial anatomy. Ligaments function is to hold bone to bone, and tendons function is to hold muscle to bone. So if we picture maybe a muscle right here, a tendon is going to go from that muscle over into the bone like this. This would be a tendon. Okay, holding the muscle to the bone, versus a ligament is going to hold this bone to this bone. Ligament. Tendon holding the muscle to the bone, ligament holding bone to bone. Okay. We also have nerves and blood vessels that obviously will supply the joint with detecting the amount of stretch in the joint. That's the function of the nerve. And then the blood vessels are going to nourish the joint tissue. So not necessarily the chondrocytes, but all of the other tissue inside of that, that joint will be nourished by the blood vessels. All right, and finally, the last thing inside of the synovial anatomy is our articular cartilage. I'm going to draw this as yellow, but I'll just keep writing in blue. So this articular cartilage is at the end of the bones, like this. Does that make sense? So that's our articular cartilage. It is made of hyaline cartilage, and it's found at the ends of all bones, and its function is to reduce friction and absorb shock. Potentially something you could be asked on the test about this is what happens if you lose it? So what happens if you lose the articular cartilage? You get arthritis. So your bones actually start to deform because they rub against each other without this cushion. Okay. So that was everything for the anatomy of a synovial joint. Okay. Now we're going to talk about the accessory structures really quick, and then we'll move through our movements, and then we'll get going into cartilage and bone. Okay. Any questions there on the anatomy of the synovial joint? That kind of makes sense. We're talking about how it looks and the different terms within it that you need to know. And I tried to just highlight what will be the key points of what will be tested. Remember that there's more that could be on the test. Okay, I don't want you to feel like I'm covering everything. I'm just getting most of the main points. If you're missing something I'm writing, then I would definitely say you need more detail in your notes, because I should just be covering the main points. So bursa, these are accessory structures of the synovial joint. There are 3, and I'll just give you their quick definitions. So bursa, their function is to accommodate pressure in the joint and to alleviate friction. They are basically like little pillows, friction like pillows. For the test, you need to know that there is a condition called bursitis. This happens if the fluid inside the bursa crystallizes and forms like a rock. So instead of having pillows in your joints, now you have little rocks. So it's very uncomfortable, obviously, and this is called bursitis. Okay. The next one is the tendon sheath. Tendon sheath, these wrap around elongated tendons. So these are actually elongated bursa. So their function is going to be the same. They're helping where tendons rub together. You don't get bursitis of the tendon sheaths. You just get bursitis associated with the bursa. But tendon sheaths are technically elongated bursa. Where they are found is in the feet and the hands. Finally, the last accessory are the fat pads, and these are used as insulation and packing in the joint. So those were the accessory structures of the synovial joint, just 3. And then we also have our different planes and types of movements, and I'll give you guys that, and then we'll talk about a quick mnemonic that you can use for those, and then the locations that are the most tested on the exam for them. So for our planes, again, this is still of the synovial joint, okay? So accessory structures was one thing, and now we're on to planes. There are 3 planes. There's the uniaxial plane. The uniaxial just moves along one axis. And then there's the biaxial plane. And this moves along 2 axes. And then lastly, there's the multi-axial plane. This moves along 3 or more axes. An axis means, once we show the examples, it will make more sense. So let's say that we're on uniaxial. This has 3 you need to know. And then the biaxial is going to have 2, you need to know. I'm drawing a line so you know that it's for each one. And then the last one, multiaxial, just has 1. So there are 6 altogether. So uniaxial has plane joints, hinge joints, and pivot joints. Biaxial has condylar joints and saddle joints. And then multiaxial just has 1, the ball and socket. So let me give you guys an example of where these are. So the plane joint is in your carpals and tarsals. This is the hand and feet, hand and foot. The hinge joint would be your elbow or your knee. And the pivot joint is the atlantoaxial joint of your, I don't know exactly how to say this in normal terms. I'll just say of top of your neck. So if you picture your head, so the top of your neck is called the axis, and then the atlas is the bottom of your, axis bottom of your head, and then the atlas top of your neck. So when you move your head back and forth, you pivot your head. Yes, pivot joint, you pivot your head across one axis. So that's why it's a uniaxial, because you're pivoting it across one axis. If you hinge your arm, isn't that just going across one axis? Do you see what I mean? I can't I can't make my elbow go like that way and that way. I can do it side to side, but that's not the same joint. This joint only goes one way, uniaxial. Does that make sense? The plane in my hand only goes across one way. So plane, hinge, and pivot. Condylar, the one we want you guys to know, is the metacarpophalangeal joint. There is a diagram. Let me try to spell this correctly. There is a diagram on the PowerPoint slides that will help you. Phalangeal joint. This is in your thumb. So the metacarpophalangeal joint is in your thumb for the condylar joint. And then the saddle joint, should be an example on that slide. I don't have an example of that for you. Ball and socket is your hip and your shoulder. Okay. So the way that I remembered this when I took my test is I actually made a little mnemonic for it. So I'm going to just erase a little bit up here because I'm out of room down here. So I did Penelope has pink carnations she bought. And then I knew that the first 3 were for uniaxial. The next 2 were for biaxial. And then the last one was for multi. Does that make sense? It goes 3, 2, 1. So on the test, I just wrote out Penelope has pink carnations she bought to remember plane, hinge, pivot are uniaxial. Condylar saddle are biaxial. And ball and socket is multiaxial. Does that make sense to everybody? So I think the mnemonic is helpful. I think it helps you on the test not to get confused which ones go with which plane. So for the test, you might be asked which axial they are. So is pivot a uniaxial? Is it a biaxial? And I don't have a location for saddle. Let me see real quick. Saddle, it looks like it's between the trapezium of hand. So what was I saying? Oh, so make sure you know locations of them. We'll ask you locations, and then we'll also ask you which axis they move across. Is that good? So the locations I gave you should be sufficient, but you can also take a look at your PowerPoint for additional locations. All right, any questions at all there? We're almost done with articulation. We're just going to go over the different motions really quick, and then we'll move on to a cartilage and bone outline. Everyone still with me? So we're almost to the end of synovial. We did anatomy, that was like the whole, basically when I drew this picture and we talked about the whole structure. Accessory structures was bursa, tendon, sheaths, and fat pads. And planes we just talked about with the mnemonic Penelope has pink carnations she bought. Movements is what we're doing, and then that'll be the end of articulations chapter. Okay. So going into that, synovial joint, this should be stuff you guys already know for the most part, except we're adding one that's new. So gliding motion. This is a G. Gliding motion. This is your new one. This one does not, the angle of the joint does not change. So these are our plane joints. I just talked about those, right? Penelope plane joints. And we said that those were between the carpals and the tarsals, right? The next type is your angular motion. Hopefully this is now ringing a bell for you. Angular motion. This is our flexion, extension. I'm not going to go over what these are again because you've just finished studying for that last exam and you should still have your notes on what each of these do, right? So check out your notes one more time if you need to freshen up on these. So these will be on lecture exam number 2. So when we say it's not comprehensive, it's not, but we'll make it clear if we're retesting you. So you will be retested on these same terms again for all the types of movement. So flexion, extension, hyperextension, abduction, adduction, lateral flexion, medial flexion, and circumduction. All of these are angular motion. Rotational motion is going to be your lateral and medial rotation. And then your pronation and supination. If any of you guys need help on any of these, just let me know. I am tutoring today from 11 to 12. So if you need me to go over any of these, I'm happy to. But just because for the sake of time and technically you should have notes on them, I won't go over them here. But if you have questions on them, I can do them in tutoring. So depression, elevation, these are our special movements. Dorsiflexion, plantar flexion. By the way, I also know that it feels irritating to have to go over these again, but if you are going in the direction of nursing or something else in the medical field, you actually really do want to know what these are because believe it or not, we come back to these a lot more than you would think. So I do actually still use these quite often in nursing. Okay. So those are our 4 types of movement across the synovial joint. And those are, you need to know definitions of each of those for your exam. And the rotational moves across a longitudinal axis, angular increases or decreases the angle between the joint. Good. All right. Any questions at all on articulations? All right, you guys ready for cartilage and bone? Okay, so for cartilage and bone, so remember that this is our next kind of topic on the exam, and then we'll get going tomorrow into cardiovascular system. We have our cartilage, and then we're going to talk about our bone, right? Kind of splits it up into 2 sections. So when we talk about our cartilage, the first thing we're going to say is some characteristics, and I'm going to just write them up here. So cartilage is avascular. Cartilage does not have any blood vessels, so no blood vessels. Just to be very clear, because this was really confusing for me on my exam, no blood vessels are found in the cartilage itself. I, for some reason, started getting confused and thought that that meant there was no blood vessels in the joint. But just to show you guys one more time, right? Our joint does have blood vessels. It's just that there's no blood vessels in the actual cartilage. Does that make sense? So no blood vessels in the cartilage, but the joint would have blood vessels. So make sure you realize that's what we mean by avascular. We're just talking about the cartilage. Cartilage has chondroblasts that give rise to chondrocytes. So before you guys just learned about the chondrocytes, now we're having you learn the new one, chondroblast. The chondroblast produces matrix, and then once enough matrix is produced, we're going to have the chondrocytes that maintain the cartilage structure. Okay, and then we'll talk really quick about the process of how they do this and then where they actually go through their growth. Remember, we have our 3 types of cartilage. I'm writing them up here because I'm pretty sure at this point, this is something you also would have in your notes. Elastic cartilage, ears and epiglottis. Fibrocartilage, remember you had your locations, pubic symphysis, knees, vertebral column. Hyaline cartilage was found in a lot of different places. This is something that you guys should have in your notes again, so I'm not going to rewrite that. Go back to your notes for locations on those. So you would want to know those locations again. Good. So our chondroblasts give rise to our chondrocytes. And then what are our functions of cartilage? Functions of cartilage. Cartilage functions to support soft tissues. That's one of its functions. It also functions as a gliding surface at articulations. Okay, so basically within the joints, those glide past each other. And then it's also a precursor model for bone growth. So in babies, right, babies are born with a hyaline cartilage skeleton. Hyaline cartilage skeleton. So those are your 3 functions of cartilage. Now for growth patterns in cartilage, we're going to talk about 2 growth patterns in cartilage. We're going to talk about our interstitial growth and then our appositional growth. Appositional, can everybody read this? Sometimes I'm worried you can't read it. Interstitial. Oh, why did I have to do that? Sometimes my pencil does this thing where it like suddenly goes big. I'm not really sure why. Okay, so these are our 2 types of growth. Interstitial is going to be 3-dimensional growth with the newest cartilage on the inside, and then it will basically build it out. So it's when we think about like a not bowling ball, a basketball, and if you picture putting air into the middle and it growing bigger, that's interstitial. Putting newest stuff on the inside so it gets bigger, growing out. Appositional is basically the opposite. We get growth on the periphery. The periphery, the word periphery means the borders. So we get growth on the periphery of the cartilage, and the word for that is perichondrium. So on your test, we might ask you which one of these has growth at the perichondrium, and that would be appositional growth. Good, so those are 2 growth patterns. But the big thing that you want to know for the test is that the growth patterns are different, but the process of growth is the same. See, my pencil's doing that thing again. Okay. Process of growth is the same. So what we're going to do is we're going to start with 2 chondroblasts in one lacuna. And then those will produce matrix. Remember, we have chondroblasts that produce matrix. So those will produce matrix enough until they each become their own chondrocyte in own lacuna. So do you guys see how now we have 2 chondrocytes, each in their own lacuna? That is the process of growth. The process of growth is always the same, whether we're looking at interstitial or whether we're looking at appositional. 2 chondroblasts in the lacuna, these produce matrix until we get 2 chondrocytes in their own lacuna that maintain the cartilage structure. If it's growing at the edge of the cartilage, we call that perichondrium. If it's growing with the newest on the inside of the cartilage, we call that interstitial. So at the perichondrium, appositional, on the inside, interstitial. Good? Any questions there? So that's actually everything you need to know for cartilage. Okay. So the big thing you want to take away is definitely the interstitial versus appositional, and that the process is the same, understanding that, and then the location of them. All right, so let's do a few little introductory things about bones, and then we'll get into talking about bones. The bones part is a little bit longer, but still not too long. So there are 206 bones. On my test, I did not know that we needed to know how many bones there were, and I was a little bit surprised when I was asked. So now you know. Functions of bones is to store calcium. I'm going to list our functions, and then we'll go over some more stuff on the next page. Functions, they store calcium, they move the skeleton, right? Help us with movement. They function for protection and support. I feel like that's pretty obvious. They like protect your lungs and your heart with your rib cage, protect your other tissues. They store phosphorus. That's another mineral they store. And they also store fat in the medullary cavity. Okay. And finally, their last function here is hemopoiesis. This is the making of blood. So this is for sure their most, like, one of their most important functions is the making of blood. So again, these are our functions of bone, and everything else we did was for cartilage. Okay, so let's talk now about the classifications of bone, anatomy of bone, and then we'll go over some composition and a little ossification, and we'll be done. Okay, so the bone does go on a little bit longer, but we should be able to finish it. Okay, so for bone, we have our classification. Bones are classified into long bones. Long bones would be an example, would be the femur. These are obviously longer than wide. Don't really know that it's necessary for me to write that out. I feel like it's pretty straightforward, kind of makes sense. Short bones are going to be short, nearly equal length and width. Examples are the tarsal and carpal bones in your hand and your feet. Flat bones, these are going to be your ribs, your skull, your pelvis, sternum. Okay, so these are all places where you can picture that the bone is very flat. The important thing about flat bones is that they have no medullary cavity. They are all myeloid tissue. And this is our first time hearing about myeloid tissue, but basically myeloid tissue is where, I'm going to try to write it in red, where hematopoiesis, remember this is the making of blood, occurs. So making of blood happens in myeloid tissue, in the outside of the medullary cavity. So what we're saying here, flat bones are the main site of hematopoiesis. So in flat bones, hemopoiesis, the majority of hemopoiesis is happening because it's all myeloid tissue. Does this make sense? Flat bones are all myeloid tissue, all hemopoiesis, hematopoiesis is occurring there. It's either hemopoiesis or hematopoiesis, both are the same thing. Lastly is irregular bones. An example here is vertebrae. Those are our bones according to classification: long, short, flat, and irregular. Bone according to anatomy of the bone, we have our epiphysis. The epiphysis is the head of the long bone, and it is our attachment site for tendons and ligaments. So that's where our tendons and our ligaments attach. If we're picturing that, right, that like femur type of bone, this would be the epiphysis, right? Also called the head of the long bone. These have myeloid tissue. Okay, and remember, myeloid tissue is where our hematopoiesis is happening. The next part, I'm going to do a 1, and then I'll just erase this here because it's a little bit away. 2, let's change our color. Metaphysis. So the metaphysis is the meeting point or the connection point of the head and the shaft. It is where the epiphyseal plate or the growth plate is located. So here and here would be our metaphysis. So the growth plate or the epiphyseal plate is thick hyaline cartilage that ossifies. Ossifies means turns into bone. If you guys are on the exam and you see the word ossifies, that means turns into bone. So it's thick hyaline cartilage that ossifies or turns into bone as you grow. Remember that this was a type of joint. This was a synchondrosis joint, if you remember all the way back to when we have talked about it before today, right? We talked about it right here, and we said that the synchondrosis joint was located at the growth plate or the epiphyseal plate, and then that was where we had talked about that before. So now we're saying that in the bone, that's at the metaphysis, and that's where the actual epiphyseal plate or growth plate is located. Now, when you go through puberty and it actually ossifies, it changes its name, and we call it the epiphyseal line. So on the test, what is it called when you're growing up? It's called the epiphyseal plate or the growth plate. Good, epiphyseal plate or the growth plate. Epiphyseal line is what it's called, or it changes its name to when you actually finish growing and it ossifies. The third, I'm out of room, but I'm going to just write it over here. So the third anatomy is the diaphysis, and the diaphysis is our, let me just do a different, well, I'll do it like this and then I'll just do it in yellow. Diaphysis is the shaft. There's not a whole lot of like about, but that would be all of our section here. Good. Epiphysis, where myeloid tissue is. If it's myeloid tissue, what does that mean? Hemopoiesis, right? So we'll kind of highlight that in red. Metaphysis was in the middle, and then diaphysis would be the shaft. Okay. All right, so continuing on with the anatomy of the long bone. So we have some more kind of terms or structures that we talk about. We talk about let me see if I can just get this guy down here and fit some more. So diaphysis, shaft. So we talk about the articular cartilage. This is another structure associated with the anatomy. I've already mentioned it to you before, right? Remember, the articular cartilage is kind of this thin layer at the ends. It's a thin layer of hyaline cartilage. Remember how I said that if that wears away, what do you get? You get arthritis, right? So I've kind of already mentioned that. Now with the medullary cavity, the medullary cavity is going to be also called the yellow bone marrow. It's a hollow portion on the inside, hollow inside of shaft of long bone, and it functions to store fat. So if I kind of drew a little section here, you could picture that being filled, I'll just draw green, with fat on the inside, and that would be our medullary cavity. And we call the medullary cavity yellow bone marrow because it stores fat. This is not like your fat, like a person is fat because they have fat in their bones. We want that fat to be inside of the bone, okay? Hemopoiesis is the same as hematopoiesis. They're just different things for the different names for the same thing, which is the making of blood. Okay. Sorry, I should have written that together. Hemopoiesis, hematopoiesis, same thing. All right, so that was the articular cartilage and the medullary cavity. And now I think I'm just going to erase this here since you probably already got that written down. And then I'm going to keep writing on this page because this is where I have my bone already drawn out. I'm thinking that if you guys have to go, that's fine. But I'm thinking I'm just going to go like 5 minutes, hopefully no more than 5 minutes over our time since I started a few minutes after, because I'd really like to try to finish bone today, if that's okay with everyone. So I'm just going to try to get bone done. So if you come tomorrow, I won't be recapping, right? So I just am going to try to get that covered today. So for our foramen, these are holes in the bone that allow nutrients to get in. This is because your bone is very hard. Remember, it's made of the hydroxyapatite, if you remember from last lab exam. So there are 3 different foramens, each going into an area of the bone. So there's an epiphyseal foramen. You can pretty much get where that would go, right? The epiphysis. Then there's the metaphyseal foramen. These are just holes that get nutrients into that part of the bone. Finally, we have the nutrient foramen, and this is a hole that gets nutrients into the diaphysis of the bone. So this is the only one that's a little bit weird because it's not named exactly like that. Does that make sense? So if you're on the exam, what does the nutrient foramen supply? The diaphysis. So supplies that part of the bone. That's probably how it'll be given to you on the exam. What does it supply? And you would say diaphysis. All right, so then we have the covering around the bone. So the covering around the bone is called the let's see, let me see if I have another color I can use. Let's do blue. The periosteum. Okay, so this is the dense, irregular covering around the bone. The periosteum is like a thin tissue that covers, we're going to kind of try to draw it here. So it covers the outside of the bone, something like this. That kind of makes sense. It's going around the entire thing. But the bone, we said, is really hard, right? And it's hard to penetrate. So this perforating fibers, this periosteum is anchored to the hard hydroxyapatite of the bone by perforating fibers. So perforating fibers are like fingers that attach the periosteum to the hard matrix, which is called hydroxyapatite of the bone. So you can kind of picture they're like these weird little spider fingers that will then anchor the actual periosteum to the hydroxyapatite of the bone. So muscles will attach to tendons, right? Tendons actually bury themselves into the periosteum using these perforating fibers. So that's kind of an important topic to know for the test, right? If you have a muscle up here, a muscle is then going to join and become a tendon. So a muscle, a tendon, and then it's going to attach into that periosteum. Okay. The periosteum contains osteoblasts and osteoprogenitor cells. So we're going to talk about what those are in just 1 second here. And that we'll see what our ending point is here, but we'll get through as much as we can. So the periosteum, again, for the test, you need to know, contains osteoprogenitor, and osteoblast. Okay, so those are the two types of cells you need to know are found in the periosteum. We also have the endosteum. It's a little less complicated. It lines the medullary cavity. So you can see the medullary cavity there. So if I draw a little red line, this would be our endosteum. Okay, so I'm going to erase this and we'll do a little about on that. Okay, so for the endosteum, this lines the medullary cavity. Okay, lines the medullary cavity. It has the osteoprogenitor, the osteoclast, and the osteoblast. Those are the three cells that are found in the endosteum. And it is dense, irregular connective tissue, just like the periosteum was. Okay, so you do need to know locations of this stuff, and you need to know kind of the key things I highlighted. If I wrote it down, that is pretty much guaranteed to be something you're going to be tested on. So make sure you have, all the stuff I wrote down in your notes, because those are definitely the key topics for the anatomy of the long bone. Okay, so just looking at this, I'm seeing, I don't think I can get through all of this in 5 minutes, but hopefully we can. Thinking we'll just spend 15 minutes tomorrow and finish it up, because I'm looking at it and I think that'll probably go better. If you guys are okay with that, we're kind of almost there, but I don't want to rush through it too much if you guys are ready to go today. So we'll just spend 10 to 15 minutes tomorrow working on finishing it. So we'll finish up the cells of the bone, a little bit about the bone marrow, and just some different ossifications pattern. Like I said, 10 to 15 minutes. And then we need to do heart and cardiovascular system. So tomorrow's going to be a big day. Thank you guys for coming. If you have questions on anything, please stay. I'm here until noon.